Welcome everybody to our Tech Talk. We are joined here with Terry Tilley, who has taken a deep dive into CS Core Stack best practices. Before we go any further, let's all unmute ourselves and give Terry a round of applause.
Let's go!
Terry.
All righty, and whenever you're ready, Terry, take it away.
Thank you, Kat. I mean, with an ovation like that, I mean, who wouldn't feel amazing? We're definitely going to go into CS Core Stack best practices, but it would not be possible if I did not give a thank you to Single Sprout for sponsoring this Tech Talk series. So let's get to it. Like, what is Core Stack practices? In trying to really think about what I wanted to put together for this Tech Talk, I decided to really focus on like the core principles of like computer science, right? Which is kind of the undertaking, the underbelly, if you will, of computer programming. And so in going into that, these four things are what we're going to talk about. But I was thinking, man, what else do people really like? What else do people really need? In addition to computer science, because I feel like everyone needs computer science, right? And so I decided to go with food. So when I say food, I'm thinking if you've ever been to a buffet pre-COVID, right? A buffet is an entire offering of all types of cuisines, things that you can indulge in, excuse me. But what I'm offering today is going to be an indulgence in all the different things that really make up CS, right? First and foremost, we talk about algorithms. It's literally the ingredients of computer science. And I call it the recipe of programming. So again, we're just going to highlight and touch on some things that are best practices. We all have used algorithms. And if you're a person watching this brand new, you've never done an algorithm, there's a lot of different resources out there. You just Google algorithms, how to do it. You can come up with everything. One of my personal favorites that I was introduced to almost a year ago was from Colt Steele, who's a best-selling instructor. And he came up with these 5 steps on approaching every single algorithm problem. Obviously, they're pretty straightforward, right? Understand, explore concrete examples, break it down, solve or simplify, and look back and refactor. But the core principles of it, he actually took from George Polya's book called How to Solve It. I'll let you look up exactly what year that was published. The key thing is, can you in step 1 restate the problem in your own words? Can you actually come up with your own concrete examples? Think of the tests that you may put together to test an algorithm out. Breaking it down, we're talking about taking the major problem and can you put it in some small, simple problems that you know how to solve, which bleeds you right into step 4, which is solve it, right? If you know how to solve the entire problem, then get started. If you only know how to solve a part, but you don't know how to do that other part, solve the parts that you know. And that way you simplify the overall problem. And of course, whenever, be very intentional about looking back and refactoring. These are some steps that can help you with algorithms when it comes to computer science, but that is not the only thing when it comes to algorithms. We're not just talking ingredients. You have to start thinking about different cuisines. And so when I'm looking at cuisines, I started thinking about data structures. In data structures, there's a litany of them. I'm not going to list them all out. Please research all the different data structures. But as an engineer, as a developer, you have to think about what is the best data structure for what I'm trying to achieve. So it's not so much the data structure itself, it's choosing the right data structure. When you look at arrays versus linked lists, do I need the time complexity to be constant as far as looking up different data points? Then maybe I need to use a linked list. Or maybe I'm more concerned or it's more beneficial for me to use less memory. So I'll go with an array. On the other side, I have in the diagram here, good old stack and queue, 2 other favorites, LIFO and FIFO, last in, first out, which is the stack, or first in, first out, which is the queue. You start considering these things where a stack is a lot better suited for maybe your runtime management, runtime memory management, versus a queue is a lot better if maybe you need things in a certain order, right? Or you need them to insert, or maybe you need to insert and delete on both sides. As it says in the middle, choosing the right data structure can be critical in your development journey. Just as in food, choosing the right cuisine if you're going to have someone come over. But when people are coming over, you're not just going to give them a cuisine. Hopefully, you're trying to give them a good old 5-course meal. And that's where system design comes in. System design is the type of concept that there's no right or wrong answer that's just going to be the perfect one for all of it. It's really dedicated on what you're trying to achieve and what you're trying to build. So there's some basic concepts, 5 of them, that I like to introduce when it comes to system design. The first one is load balancing. You have to think about as you have your web server, and your web server can get a whole lot of requests, or maybe it gets all your requests simultaneously, and your web server can actually go down, right? And so maybe you want to come up with more than one web server so you can handle that amount of requests coming in, but how are you going to decide which goes to which one? How are you going to balance them? That's where load balancing comes in. Load balancing itself is one of the main ways that you can help your throughput, your performance, your latency, and even your scalability if you have a proper load balancing schema involved. But it's not just load balancing. You also have to think about caching. Shouts out to Tash, one of my good friends who also did a Single Sprout series on caching, and also Ken Litton, who also did. I'm not going to teach you about caching, but caching also helps. I said web server before. Most of the time, it's your database server is the thing that first goes out. So when you think about caching, it's your ability to store data in other places. So when the clients, when they're trying to request data that gets requested all the time, they can pull it from a cache as opposed to having all of those operations ping to your database server, potentially sending it down. Another concept is proxies. And so when you think about a proxy server, sometimes you may have heard of it. I went to a restaurant analogy here. So if you're at a restaurant, a really nice one, you sit down, you order an amazing dish. Does the chef bring it out to you? Typically, no. You have a waiter or a waitress bring it to you. That's the purpose. That's the job of a proxy server. A proxy will take you have 2 types, forward and reverse. A forward proxy, the requests are sent to the proxy. The proxy acts as your intermediary, and it goes to the actual server database, gets your request, and then sends it to the client. The database server that you're requesting it from, or even the web server, doesn't know who requested it. They only know the proxy. In very large or complex areas, a lot of the times the reverse proxy is preferred because it protects your database server. You think about the reverse proxy because it doesn't know exactly, not it doesn't know, but the clients don't necessarily know who is sending it to them. It comes directly from the proxy. Again, another major concept to help with coordinating. Sometimes you can have a proxy do your load balancing as well. In some common slang, people say no cap, right? Maybe you've heard of that before. It's the equivalent of saying no lie, or I'm not exaggerating. But in system design, we're talking about consistency, availability, and partition tolerance. All 3 you're going to have in a database that's up and running. But in the event that you have an interruption in your database, there's typically 2 that you need to prioritize to be optimal, and you'll pick the other one that you will sacrifice. You'll allow to have, I guess you could say, less than optimal experience. For example, you have maybe in your database, you want consistency to be the most important thing. You want the data to be the most freshest data ever. And then you go with partition tolerance, right? Because you want it to be able to survive if there's a network interruption. Then you may want to go with something like a MongoDB database because it'll prioritize those. Maybe you'll go with one that's AP. You always want data to be available, even if it's not the most accurate data. The data will be updated later, but maybe availability is the most important thing. Consistency, not so much. So when you think about real world examples, CP is probably going to be, bank servers, things along that lines. Maybe AP, maybe social media website, Facebook, Instagram. The availability is most. It doesn't have to be the most current, but it has to still work. Take a deep dive into CAP theorem if you've never heard of it. But the last basic concept of system design is databases. Now, I won't go into these three different things or considerations inside of databases, but you have to think about how you want your data indexed. Do you want replication? Do you want a backup database that has all the same information, where if one database goes down, you can use the other? Or you can have one database be responsible just for reading operations and the other database be the one responding? Or even sharding or data partitioning, which is just breaking up large data and separating into different databases based on what it is. Ladies and gentlemen, these are the basic concepts of system design. And you think about, for those that may be going on interviews and things, these are things they're going to ask you about when you are trying to answer the question of, hey, you got to build Netflix in the next 45 minutes. What are all the considerations? You may want to touch on all 5 of these concepts. Lastly, that brings us to paradigms and design patterns. A little quote there from Rudolf Nureyev. I probably messed his name up. Somebody help me out on that one. The technique is what you fall back on when you run out of inspiration. And so when we think about paradigms and design patterns, talk about the technique that you're going to use. There's languages that are completely object-oriented programming. There's languages that are completely functional programming. And then you have things like JavaScript, where you can do a combination of the two. It's really imperative versus declarative, right? Object-oriented programming is more about just storing data in objects and having things like encapsulation and inheritance being the pillars of how you design or actually write your languages or your applications. Where functional programming is more about having first-class citizens. You have pure functions. It's declarative. You're more focused on the what we're doing. You take these paradigms, then you have to know how to actually apply them to different patterns. When I say design patterns, I'm not talking about a specific like structural, creational, and behavioral, not code that you write. They're a way that you structure or design or apply your code. These are your 3 main categories of design patterns. If you've never heard of them before, glad you came to my buffet. For example, you have one type of design pattern that's under structural is a decorator. Decorator for me reminds me of, let's say I got a truck, but I'm going on a trip across country and I need a little bit more space, and the cab that I have doesn't hold everything. I can rent one of those U-Haul extenders, right, and put on the back and put more stuff in it. You can do that same thing when you're writing an application using the decorator pattern. Please look into these 3, a much more deeper dive, because the more you understand these 23 different design patterns, I'm not saying you have to memorize them, but you need to be generally aware which ones are the most commonly used. And if you're asking where this came from, you look at the original Gang of 4. They wrote a book called Design Patterns, Elements of Reusable Object-Oriented Software, where they dive deep into those design patterns. Even lately, they've come up with 3 additional design patterns. I didn't include them here, but I'm sure you'll be able to find those as well. So we went a whole lot here, but you can't prove everything with statistics, but you can always find something good or bad to say. Rapid stats time, 4,859,000. That was just a random number. I just wanted to make sure you're paying attention. That is a large number, but no, here's some real stats. 72.6% of web developers say they prefer the title web developer. They gave them a lot of different choices. The reason I brought that up is you look at Codesmith graduates, most of them get hired for job titles called software engineer or even front-end developer, but it doesn't matter what you call yourself. Codesmith grads can do it all. Top percentages of graduated employees, salaries of graduates, But then we were talking about food. And so when it comes to 1.4 billion tons, that's the amount of food we waste every year. So what I want you to do is don't waste the information that I gave you today. A true teacher would never tell you what to do, but he would give you the knowledge with which you can decide what would be best for you to do. I'm going to give you a couple of resources, some of the ones I use. It is not all inclusive, but I want you to consider taking that deep dive. As Albert Einstein said, wisdom is not a product of schooling, but of the lifelong attempt to acquire it. Thank you, ladies and gentlemen.
All righty, y'all. Let's unmute ourselves and give it up one more time for the one and only Terry Tilley.
Yeah.
Yeah. All right, now let's open the floor to some questions. Eros?
Hey there, Terry. Great talk. You definitely made me very hungry. I ate dinner a little early because of you. I wanted to say, so for people who are beginners and want to delve into computer science, what of the 5 best practices did you, or the course stack, do you think that someone should try to approach first? If, let's say, they wanted to be a full stack engineer. Let's stick with full stack.
Absolutely. First off, thank you for the question, Faraz. And so you look at those 4, you have to start with algorithms. It's the bare bones ingredients of everything that you're going to do. And once you understand algorithms and then data structures, then you can start to look at system design. What are the different trade-offs between using a NoSQL non-relational database versus a relational database? Should I use a proxy server as a load balancer just good enough, or should I do a combination of the two with some of the different technologies out there like Cassandra that actually offers both? So you start with the building blocks and then you work your way up, Faraz, is what I would tell them.
All right, thank you, Terry.
Very welcome.
Any more questions?
I think they're hungry, Kat.
Alrighty, that will conclude our Tech Talk for today. Thank you everyone for joining us for our Single Sprout Tech Talk series, and enjoy the rest of your evening. Bye everyone.
Thank you.
Thank you.